Hello, today we're going to be looking at the algebraic properties of equality and using those to justify the steps we take to solve equations. So our properties that we're going to be talking about today are the addition, subtraction, multiplication, and division properties of equality, as well as the distributive property. You've already used all these with solving equations earlier this year. Now we're just being more formal about the steps we're taking. This will help us with proofs down the road. So, what we're going to do here is we're going to solve these equations and then say what property we use to do each step. So looking at this first one, we know we need to get the p terms on the same side of the equal sign. There's a couple of different ways you can do that. I'm going to choose to subtract 2p from both sides. So then the property I'm using there is the subtraction property of equality. I'm just going to write subtraction, but technically the full name is subtraction property of equality. When I do that, 2p's cancel. I get negative 9 equals 10 minus 2p is 8p minus 17. From here, what else do I need to do? I need to undo this minus 17. The way I undo minus 17 is I add 17 to both sides. Since I'm adding the same thing to both sides of the equation, I'm using the addition property of equality. Negative 9 plus 17 is positive 8. 8p stays the same. Those 17s cancel like we expected. We are nearly finished. The last step I need to take to get p completely by itself is I need to divide by the number in front of p, which is 8. Since I'm dividing both sides of the equation by the same number, that means I just use my division property of equality. Now I'm done, I just need to actually write my answer. 8 divided by 8 is 1 equals p. So 1 equals p or p equals 1. Let's try another one. So I have 39 minus 5z equals negative 1 plus 5z. I'm going to start by getting my z terms on the same side, so I'm choosing to do this by adding 5z to both sides. Since I added the same thing to both sides of the equation, I used my addition property of equality. 39 stays the same. These cancel because we used opposites. Negative 1 stays the same. 5z plus 5z is 10z. What else do I need to do? I need to get rid of this minus 1. The opposite of minus 1 is adding 1. So once again, I'm using my addition property of equality since I'm adding the same thing to both sides of the equal sign. 39 plus 1 is 40 equals 10z. Last step, I need to get z completely by itself, so I need to divide by the number in front of it. Since I'm dividing both sides of the equation by the same thing, I'm using my division property of equality. 40 divided by 10 is 4 equals z. For this next one, we have a number in front of parentheses. In case you forget, when we have a number in front of a set of parentheses, we need to distribute that number to everything inside the parentheses, aka multiply everything inside the parentheses by 2. 2 times x is 2x. 2 times 1 is 2 equals negative 4. So what I did to get from here to here was I used my distributive property. Now this looks more like the other equations. Undo this plus 2 by subtracting 2 from both sides. So that's my subtraction property of equality. And then last but not least, I need to divide by the number in front of x, which is 2. That's using my division property. Since I am dividing both sides by the same number, I get x equals negative 3. We can also use these properties to solve what's called literal equations. Literal equations look like this. You should have seen them in Algebra 1, but basically they contain more than one variable. So I can't solve this equation and get, like, for instance, b equals 2. I'm only going to be able to rearrange it and get one of the variables by itself. So notice here it says solve this equation a equals 1 half bh for b. That means we want to get b by itself. So it's going to be using these same properties we've been using, adding, subtracting, multiplying, dividing, distributing, except for instead of ending up with just a number answer, you're going to end up with a rearranged equation. So the goal here is to get b by itself. There's a couple different steps you need to take here. The order is not super important. There's a couple different ways you could go to start. For me personally, whenever I see a fraction, I want to undo that fraction first. So in order to undo this 1/2, I can do the opposite of multiplying by 1/2, which is the same as dividing by 2. I can multiply both sides by 2. So I'm going to start with that. I'm going to multiply both sides by 2. So that's my multiplication property of equality there, since I'm multiplying both sides by the same thing. 2 times a is 2a. 2 times 1/2 cancels because 2 times 1/2 equals 1. So there's no longer a coefficient in front of bh that's not 1. You could write the 1 there, but we don't have to. So now this side is just bh. I am closer to having b completely by itself. What else do I need to do to make that happen? BH really stands for B times H. So to undo multiplying by H, I do the opposite, which is dividing by H. So now I'm going to use my division property of equality. H's on this side cancel, which is what we want. This side, we cannot simplify any further because we do not know what A and H are. So it's going to look like that fraction 2A over H. That is it. Like I said, we'll come back to these properties more when we do proofs. Have a fantastic day.